All right, well, we've looked at solving quadratic equations when we had two real roots or two zeros or two x-intercepts or two solutions. Remember, x-intercepts, roots, real zeros, and solutions are all referring to the same thing. This is where the quadratic equation, the graph of it, will cross the x-axis, give us an x-intercept, a root, a zero, and a solution. And now we're going to look at some that are going to give us just one real solution. And what that means is that the graph, either the minimum or the maximum value, which we've discussed earlier, where that is, it is going to, I call it bouncing off the x-axis. It's going to come, it's going to hit the x-axis, and then head right back up or down, as the case may be, depending on the positive or negative value of the lead coefficient, the coefficient to the leading term, which in a quadratic is an x squared. Now, also remember that we must get our equations into standard form. Ax squared plus bx plus c. And of course, in this example here, I got both of these, I got a little bit of work to do that. So I'm going to need to add 8x to both sides. And I'm going to need to add 11 to both sides. And then I got a little combining like terms to do. So after we do that, then we're going to have an equation such as x squared plus 8x plus 16. Now you might recognize something here. This will come up a little bit later on when we get into factoring. But I actually have two perfect squares in this. X squared is a perfect square and 16 is a perfect square. And we're going to learn to recognize that when we see these perfect squares on the front end and the back end of this quadratic equation, guess what? You're going to have one real zero. All right, equals 0. All right, and then before we move to the graphing calculator, I got a little bit more work to do in this case. Now I've got to subtract 48 from both sides and then add 12x to both sides. Oh, and then do some combining of like terms. And when I do all of that, I hope you can follow along. I'm not going to take it step by step. We're going to go negative x squared plus 12x. And let's see, I've got subtracting 48 from both sides. So I got 48, negative 48 plus 12. It's going to give me negative 36. Something doesn't look right here. Negative 2 plus 12x. Well, I guess that's it. Anyway, something doesn't look quite right. All right, we're going to graph it and see what we get. Hold on, we're headed to the graphing calculator. All right, so we're here on the calculator. We're going to graph these two equations that we rewrote, so that we could get it in quadratic and standard form. And of course, we're looking for that is going to give us one real solution. So let me graph this first one. We're going to clear here, and it was x squared plus 8x plus 16. And we're going to hit the graph button. And boom. Okay, so this is where we see it comes down. We're coming down, hitting down, 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 and then hit the x-axis where x is equal to -4, and then it bounces off and takes off and heads up out towards positive infinity. So let's go in and we'll just take a quick peek at the table, and I see here at -4, y is equal to 0. That indicates my 0, and we can see as we go more negative, we're headed up towards positive infinity. And as we're moving towards, from -4 towards x approaching positive infinity, we can also see that our end behavior, our f of x, is also headed towards positive infinity, where we got one real 0 where x is equal to -4. Now let's go graph this second one, and we should know here from our end behavior, when we looked at minimum and maximum, that the fact that we got a negative coefficient on this x squared is that we're going to now have a maximum value. Our quadratic equation is going to be reflected across the x-axis. Let's see, so we got plus 12x minus 36. I know why I thought something was wrong. It's because of that negative coefficient. All right, and we're going to hit the graph button again. Let's see what we got. Okay, well, there we go. See, we're seeing it. Okay, we're coming from negative infinity, moving up, moving up, moving up. We hit the x-axis where x is equal to 1, 2, 3, 4, 5, 6, and then we head back down into y equals negative infinity, or approaching negative infinity. And we're going to take a quick peek at the table, and we should see that when x is equal to 6, scroll down, y is equal to 0. And our range is such that f of x such that f of x is less than or equal to 0 in this particular equation. Our domain is all real numbers. All right. Now we'll next look at, in a few moments, where we have no real solution.